In this video, we've got these questions on board, right? Two of them. The first question, we have to identify the polynomial and their degrees. Then the second question, which can be considered a polynomial. So out of this expression here, which one can you consider to be a polynomial? If you see, it's not all about the simple expression we introduced earlier. So just looking at these, which ones can you call a polynomial? Alright, we'll come to question number 2. Later, let us first look at question number 1, where we have to identify the polynomial and their degree. So we'll start. Answers. So number 1. Look at this expression a, x squared plus 5x minus 3. That is a polynomial. So if you look at the highest power, there is 2. When you move and you have this as power 1, then this here, x raised to power 0, if you still want to put x there. 0, okay, that's 3 times x raised to power 0. So it's a polynomial because the power is a whole number, you can see that, and it's also a positive integer. So I'll write a, which is x squared plus 5x minus 3, is a polynomial, is a polynomial of degree. Now what will you say about the degree? The highest power of x in this expression is 2, so it is of degree 2. That is actually a quadratic expression, is that not so? So what have you learned? A quadratic expression is a polynomial of degree what? 2. Alright, now let us look at the next one, b. So let's see. b, x raised to the power 5, then minus x raised to the power 3 divided by 2, then plus 6x is a polynomial. So that expression is also a polynomial. Is a polynomial of degree. The highest power of x here is 5. So of degree 5. This is a polynomial of degree 5. Why is this actually a polynomial? It's a polynomial. For you to define it, simply go and check the powers. Is that okay? Check the powers. Is the power in positive integer or negative integer? That's if all the expressions are given in terms of x raised to power this, x raised to power that. Is that okay? If you look at this is x raised to power 5, then there is x raised to power 3. There is no x raised to power 4 there. You commit no crime. Alright, the reason why x raised to power 4 is not there simply means that it is 0 times x raised to power 4. 0 times anything disappears. It's 0. Is that okay? Fine. Then here you notice that the power is what? Power 1. The powers are positive integers. So that's what's the point. Okay, now let us look at c and d. c, x raised to power 4 plus 2x raised to power 3 plus square root x squared plus 1, then plus 3. Not a polynomial. Not a polynomial. Not a polynomial. Why? What's the reason? Because of square root x squared plus 1. You see, this square root of x squared plus 1 is the same as writing x squared plus 1 everything raised to power half. Square root means raised to the power of what? 1/2. That's 1 over 2. And you know that the powers of the variable is not expected to be what? A fraction. It's not also expected to be a negative integer if it must be a polynomial. So this is why this expression is not a polynomial. Then d, let's look at it. 5 exponential 2x plus x squared minus x plus 3. Not a polynomial. Not a polynomial. Not a polynomial. Because of the mix-up. The mix-up of the exponential base, the exponential base and x base. You see, you can't have two different functions as base in a given polynomial expression. It's not that. The base there is an exponential function, exponential 2x. Then the base there you can see are x terms. It's not possible. That mix-up is not allowed. It's either everything is exponential base or everything is x base. Then you now check the powers to know whether it's a polynomial or not. Okay, so we've identified those that are polynomials and those that are not. We shall take a short break. When we're back from the break, then we'll look at the second question. Very important, okay? Be thinking about that. We'll be back. You are welcome from the short break. Now let us look at question number 2, where we are to identify the expression here that can be considered to be a polynomial. You see, if you look at expression of this kind, you might just be like, wow, this doesn't look like what I know about polynomial expressions. I can see x raised to the power this, x raised to the power that. But the truth is, there are some functions that might be combined. That's the same functions. Are you getting me? The basis must be the same function. That they might be combined in such a way that their powers are written either in decreasing or increasing order. One can formulate a polynomial from there. It's possible. In fact, you're going to encounter such in the study of logarithm. You're going to encounter that. In the study of indicial equation, you're also going to encounter that. So I had to introduce it here so that once we encounter them in those topics, it wouldn't really be a new concept anymore, as in we would have gotten a background knowledge. So, question number 2. The first one, A, we have exponential 3x squared, then plus 2 exponential 3x plus 5 is a polynomial. Is a polynomial. Alright? Is a polynomial in exponential base function. In exponential base function. Because the base here is exponential, all of them is exponential. Then look at something. Having identified that this is exponential, and take note, the powers of the exponential must be the same. That's why you have exponential 3x, exponential 3x. This 5 is actually carrying exponential 3x bracket raised to the power 0. This part is actually bearing 5 exponential 3x bracket raised to the power 0. So now, having identified that the bases are exactly the same, you can see exponential 3x, exponential 3x. Then look at their powers. I've also told you this is exponential 3x, but the power is 0. Look at the powers. The power of this exponential 3x here is 2. Then look at this one. The power of exponential 3x here is 1. This is exponential 3x, all raised to the power 1. Is that okay? And then I've explained that this 5 standing alone is the same as 5 exponential 3x, all raised to the power 0, because I had to write it in exponential base form, knowing that these ones are exponential 3 base form. Is that okay? That's exponential 3x. You see what I did here, right? Good. Let us go to the second one. The second one is exponential 3x raised to the power 2. Please, before I move on to, with this, if you work on this, we can call exponential 3x, we can say let it be equal to p. We can say let it be equal to y. Now if I say let exponential 3x be equal to p, this will become p raised to the power 2 plus 2 times p raised to the power 1, then plus 5. It's made of 5p raised to the power 0. P raised to the power 0 will give you 1. 1 times 5 will give you 5. Am I communicating? Correct. Now let us go. So the second one, you see clearly that this second one is not a polynomial expression. We can't consider it as polynomial. So I'm going to write not a polynomial. Not a polynomial. Now what is our reason? Because of mixed up base. Mixed up base. You've explained something like this for question number 1 previously when we treated this fourth expression. So you have, look at this, an exponential function base. Then along the line, it is true, this is raised to the power 2 here, this is raised to the power 1 here. But look at the base here, the variable is x, no longer exponential. So you cannot have this mix up of different functions as base. Okay, so we move on to the third one, sine cube x, This sine cube x is still written as sine x all raised to the power 3. Is that okay? That's the meaning of that. So sine cube x plus 2 sine square x minus 4 sine x plus 2 is a polynomial. You would agree with me, following the explanation I gave for the first two here, is a polynomial. Now it's a polynomial in trigonometric base function. base function. The trig function there is sine. Now if you look at this, I've told you this can be written as sine x all raised to the power 3, 2 times sine x all raised to the power 2 minus 4 times sine x raised to the power 1. Then this 2 is the same as 2 times sine x all raised to the power what? 0. Does that make sense, right? So you notice that the bases are all the same. All the bases are sine x, sine x, sine x, sine x. Does that make sense? Then now look at the powers. You now notice that the power is positive integers. Alright, that's positive whole numbers decreasing from 3 to 2 to 1 to 0. The highest degree here is degree 3. So we can actually convert this to a polynomial expression of degree 3. Let's take a short break. When we come back, we'll analyze this as another polynomial expression in this question 2. And now we want to look at the last expression here. Is that okay? We are to find out whether it can be considered as a polynomial or not. Okay, let us look at this. So I'll write for 2d, what we have there is 2 raised to the power 2x, then minus 3 brackets 2 raised to the power x minus 4. Now let me show you something quickly. Let's look at something. Do you know that this can be written as, this is the same as 2. Now what do I want to do? I want to shift this 2 backward like this and then this x forward. So it's going to be 2 raised to the power x. Of course, you know the power is actually 2 times x. So it's the same as x times 2. The point here represents times. Is that okay? I've done the shifting here. And if I shift that, I can actually put this in bracket like this. I can actually put it in bracket this way. So that this will now be minus 3, 2 raised to the power x, then minus this 4. Take note of something now. You notice that each of the terms here have the same base. And the base there is 2 raised to the power x. 2 raised to the power x. In fact, this 4 here is the same as 4 times 2 raised to the power x. Everything raised to the power 0. Remember, a term raised to the power 0 will give you 1. Then 1 times the 4, you maintain this, your minus 4 there. Does that make sense, right? So I commit no crime. I am still mathematically consistent if I say that this is 4 times 2 raised to the power x, then everything raised to the power 0. So you now notice that this expression has the same base, 2 raised to the power what, x. And then you notice the powers decrease. This is power 2, this is power 1, this is power 0. Therefore, 2 raised to the power 2x minus 3 times 2 raised to the power x minus 4 is a polynomial. Is a polynomial expression. Is a polynomial expression in 2 raised to the power x base. Is that okay? That is in 2 raised to the power x base or in base 2 raised to the power x. In fact, you will encounter things like this under initial equation in indices, as we will treat in this course. If I choose to call this 2 raised to the power x as maybe k now, you notice that this becomes k raised to the power 2 minus 3k. That is 3k raised to the power 1, then minus 4k raised to the power 0. K raised to the power 0 give us what? 1. 1 times 4 give us, that's the minus 4 here. So you see that there are some expressions that might be given to you. Looking at it directly, they may not look like polynomial, but if you look intently with the GMAT 41's eye, you would notice that that is actually a polynomial. In the next video, we are going to introduce addition and subtraction of polynomials.